Cool. So let's get started. I guess I'm between you and your dinner and drinks, so let's make it happen. So this session is about components. It's about what you can build with components and technologies. So with those components, what would you build? Anyone? There's no trick. Anyone? A car, right? Right, but it turns out that we, as developers, we also create bicycles with those components, right? So we select the best architecture, the best technologies, the best approaches, and then we build everything with that, right? Even also cars as well, but you know. So this is the point of my presentation. I want to highlight that depending on what this is working, yeah. Depending on what kind of application you're going to build, you got to use different components, different technologies. Okay. Right. So let's introduce myself. My name is Cesar de la Torre. I work as a .NET product manager for the Developer Tools division in Microsoft Corp in Redmond, Seattle. And yeah, probably 95% of my time is around .NET and positioning and .NET technologies. So this session is about all the .NET technologies, or all the even farther, all the Microsoft development technologies, and how you can use them and when to use different technologies depending on what kind of application you're going to build. Something I want to highlight is this session is not just a single session. We created like a mini track for business applications. So you can see that we're going to have like 3 sessions about data-driven applications, focusing on Light Switch and also Entity Framework. Then we'll have another 3 sessions about domain-driven design and approaches for mission-critical and core business applications. And finally, we will have another 3 sessions for Windows apps modernization, but talking about business applications, whether we are talking about apps for store applications or desktop applications. In fact, that WPF session on modernizing WPF applications, that's a session I'm going to deliver on Thursday. So that's why today I'm not going to focus on desktop apps, because I will do that on that session. Right. So as I mentioned, when you are going to build an application, to me it's like a tree. You have the application, which is the tree, but then the roots are the reasons why you created that application, are the business priorities or the business goals, right? So come on, yeah. So when you are going to create an application, you probably have questions like, is my application like short time to market? Is it a long-term investment, or is it a small application, departmental, or is it a long-term application, enterprise mission critical, or what do I want to do with this application? Do I want to engage with customers? It has to be like compelling application, or is it just an internal application to run the business? Those questions are not really related. Probably not. Sometimes yes, but that's probably what you usually think or you question yourself. And then depending on what are your answers, you could go and choose different technologies or different approaches. Like you could go and use a RAD, a Rapid Application Development Technology, or you could go for a loosely coupled architecture and different fine-grained components or technologies, or could be a data-driven application or a domain-driven application. I will talk about that later on. Or could be a modern app, a mobile application for the phone, for a tablet, or could be a desktop application, like a more established. Okay. Come on. Yeah. And here you have all the Microsoft development technology stack. I will be touching quite a few technologies in there. I'm not going to talk about all of them right now, because then it would be really boring. But this is what you might be questioning yourself. So there's a bunch of technologies coming from Microsoft. What technology should I use in this case or the other case, right? So this is what I want to talk about. So when you are going to create a business application, what we call foundational applications for the business, probably your application would fall in one of those two buckets. So the first bucket is about small, medium-sized business applications, and the second bucket is about mission-critical or core business applications. Could be something in between, but then you gotta pick things from one side and the other side, and then it's going to be like a mix. But the priorities are usually different. So if we are talking about a small, medium-sized business application, usually your priorities are going to be about productivity and easy to get started, something that you don't have a lot of time to create that application. And then, on the other hand, if your application is a large and mission-critical application, probably your priorities or the application's priority are going to be more about the core business, something long-term. You really want to invest there because it's for the future of your company. It's mission-critical for your whole company. So the approaches for one or the other type of application normally are going to be different. In the first case, usually the approach is going to be data-driven. The application probably is not very complex. It's just about saving and reading data. And you could use a RAD, rapid application development. On the second case, the approach could be domain-driven design or something similar. Decouple architectures. Everything is going to be more complex because you want to achieve like further goals regarding scalability, high performance, and even handling many more users, and also because the core domain of your application is more complex. There's a bunch of business logic in there, and so on. And in here, you really are concerned about the long-term maintenance. So you create the application, but then it's going to be evolving during many years, and then creating new subsystems, new stuff, new business logic, new technology, and what you need is an approach that when you are changing it and evolving that application is going to have the smallest impact as possible. Okay? This is not working pretty well. Okay. Something I want to highlight is that when I'm talking about applications, I also mean subsystems. Because when you have a large application, then different subsystems could be different. Maybe you have your core subsystem, and that should have a different approach than another collateral or a smaller subsystem, which is more about reading and saving data. So whenever I'm saying or categorizing something as an application, I could also mean subsystem, right? Just want to highlight that. So let's start with the first case, which is about small and small medium business applications. So as I mentioned, most of those applications are usually data-driven applications. And what does it mean? It means CRUD. It means that probably 90% of the application is about reading records and changing data and saving records. Could be about any domain, customers or contacts or whatever. Okay. So in that case, business logic is usually pretty low. And then, I mean, if it is something like that, it's perfectly okay to use a RAD or any data-driven approach. The only risk we have in this case is when you think this is just a small data-driven application, but then it is going to grow and evolve, and then you're putting a lot of business logic in there. And then instead of having a small data-driven application, you will end with a big ball of mud, and that's the risk. Okay, so that's something you got to be careful. But in a large percentage, many business applications are this kind, so data-driven is perfectly valid in this case. So the first scenario about data-driven applications could be a desktop application, and this is something I'm going to be talking about in my next session on Thursday, like WPF and so on. So you have different technologies for client, application services, infrastructure. In this case, because we are talking about desktop, this is what we have. You could create apps for Office or apps for Windows using WPF or Windows Forms. And then you would use usually services, whether it is WCF or Web API. So regarding services, I want to make clear that whenever you can, by default, Microsoft recommends using Web API. So if the service you want to build is HTTP, basically like a REST service using JSON or OData or XML, but it is HTTP, use Web API. This is where the future is going. If for any reason, like you need another protocol, TCP or any other protocol, and Web API, which is just HTTP, is not valid to you, then use a different technology like WCF. Okay. Then you will have different technologies for data access, like for modeling your data model or your domain model, like Entity Framework, and finally SQL or your application service, and then you could deploy that on premises or in the cloud. Second scenario would be a small, medium-sized web application. So in this case, the middle tier is going to be pretty similar. But for the presentation layer, we will be using HTML5 and JavaScript, and could be light switch. I will talk about light switch later on. And then different services, and then data. So in this case, because we are talking about a small web application and data-driven, a RAD approach would be very convenient. So, which is light switch HTML5, and also in the server or data services created by light switch. Right. So this is where I want to focus first about light switch. So light switch. How many of you do know light switch? Can you raise your hand? Okay, just a few. And how many of you have been working with it, or like creating a real application? Okay, just 2 guys. So even so, I think you are better than my session in New Orleans in the US, where less people knew light switch. So you're doing good. So light switch HTML5 is pretty new, because we had light switch like 1 year and a half and so, but the HTML5 client, it's been released in April the 4th. So I mean, it's pretty normal that you might not know it. So, but I wanna talk about that, and I'm gonna do a demo, and because light switch is great for data-driven applications where you just need to read and save data. So this is the first demo I wanna do for you. One here. Okay. So there's going to be 2 sessions about light switch, and even light switch for SharePoint. So if you are interested in light switch, I recommend going to those sessions. What I'm going to do is to create a very small light switch application from scratch. So you see here that I've got a light switch HTML application. In order to have that template, you need to have Visual Studio Update 2 installed on your machine. So let's call it Light Switch Demo Madrid. Right. And then you're going to see that creating an application with light switch is pretty simple. It's like just creating tables, data, and then screens. Those 2 concepts. And you can use external tables, or you can create a table. So underneath, it's going to use SQL Server, or Compact SQL. So if I create a table, let's call that table conference. And I'm going to add a few fields like conf name, which is going to be integer, string, conf date, which is a date type, and conf email, which is email. So you see there are like special data types. And that is important because when you create the app, depending on what data type you specified here, you're going to have like automatic validations. And the great thing about LightSwitch is that you can create a simple data-driven application almost with no lines of code, just creating the data on the screens. And then you can extend it if you want. But in this small example created from scratch, you'll see that I'm not going to write a single line of code, and it's going to be working. So this is the table. When you create a table, it's not just a single table. Underneath, LightSwitch is creating OData services. So just doing that, you could consume that table from another application, remote application, using OData services and access that data. So next item that we need is screen. So we need screens, right? Let's add one screen called conference browse conference. And then using this data. On the second screen called edit conference. Using the same data. So what you see there are all the data controls that you're going to have in your screen. But I didn't do anything other than relating the data to this screen. So by default, it's taking into account all the data fields and putting controls depending on what data you have. So you can change the order, move one control one up or down, etc. And then depending on that, your screen is going to be rendered on a different way. So in order to execute it in the browse conference, I'm going to add other controls like a button in order to select or add a new conference. So let's add a new button using like add edit new conference, and a second button called add edit selected. And that's it. So with those screens and the data, I'm going to be able to run it, and it's going to work. You can extend it. So if you are within any screen, you can write code. So because this is web, you can extend using JavaScript. Or if you go to the table, but it is not really a table, it is really a service. So we will be able to extend that service or with extensibility points using .NET. So for instance, in this table, I could extend, and when I'm updating a conference, I could do anything here in the server because it is .NET code. So later on in a different demo, I will use it. But okay, so let's run it. Oh, why is that? Browse home screen. If it should work. Oh. Okay, so I'm not sure what's going on now. I'm going to show you the other application I've got here using LightSwitch. It's a different case, but we also applied different styles. And this application doesn't have any code at all. So I'm not sure what's wrong with the other one, but So in here, you can see that we are reading records and showing information. You can edit, like this one. Or you can see the different users, sessions, and so on. And everything is just like the same way I did the other demo. We could extend it with .NET, and that's something I'm going to show you later on in order to integrate different subsystems. But it's just that simple. OK, so let's move on. To large and mission-critical applications. So in this case, when we are talking about technologies, what do you think? So probably we can use all of them. Regarding client software, could be a desktop application. Because it is a long-term application, we might be using even C++, or maybe we are creating a special module, which is a modern app for tablets or for mobiles, or a web application. And then in the middle tier, we could be using services, cache, service bus, and different, probably all the technologies. So yeah, of course, it is important to know what technology to use and when. But probably when you are creating a core business application, it's not just about technology that you care. You should also care about approaches and patterns. So this is something I want to highlight, that you should use different approaches and patterns, like patterns for applications architecture from Martin Fowler, or domain-driven design. You can read really good books from Eric Evans or Jimmy Nilsson. I brought Jimmy Nilsson to TechEd, so you can go to his session about just domain-driven design if you want to know more about domain-driven design. Or CQRS for high scalable architectures. And then the solid principles. I'm not going to explain all these solid principles, but they are like the base for loosely coupled architectures. And then the solid principles are the base for using inversion of control containers, dependency injection. So you can decouple all of your objects. So I will show you using Unity and dependency injection later on. And then you can also use BDD and TDD. So let me be clear with this. This is really important, not just for large and mission-critical applications, also for smaller applications. But make no mistake about it. If you are creating a large mission-critical application, this is fundamental. For a smaller application, maybe you could use it or not. But for a large application, this is mainstream, and you should be aware of that. And then, and this is probably one of the most important slides I've got here, is when you are creating a large application, do not try to have like your top-level architecture and apply that to every subsystem. But you should have different subsystems, or what in domain-driven design we call bounding context. And depending on what kind of bounding context you have, you should go and apply a different architecture. So, for instance, in this large application, we could have a smaller subsystem, which is data-driven, is simple. So just go ahead and create a data-driven application, maybe just ASP.NET and Entity Framework, and that's it. Maybe two layers, and keep it simple, because that subsystem is simple, so keep it simple. On the other hand, you might have another bounding context or subsystem where in there you have all your core domain, and there you want to put the code that you want to isolate from the technology, from the infrastructure technology, and then you're going to be evolving that in the future quite a lot. So probably in that case, a domain-driven design approach would be better, and applying all the domain-driven design patterns. Or if you are creating another subsystem which is high scalable, maybe there are different users competing for the same resources, then you could use CQRS, Command and Query Responsibility Segregation. And in any case, those subsystems should be integrated asynchronously. So every subsystem should be autonomous, and then if you want to propagate some change from one subsystem to the other, that should be propagated asynchronously using events. So something happened here. I create an event, which is it's just a bunch of data, like a class with data. That happened here, past tense, and then I'm putting that message, that event, into my event bus, and then it's gonna the other subsystems are gonna get that event and act depending on that. When I'm saying event bus, could be your own implementation, could be an in-memory bus, something simple. I'm going to show you later on that. Or if you have different remote servers within the same application, then you might need a full service bus, like Windows Azure Service Bus or Windows Server Service Bus or any other third party like N Service Bus or whatever. So let's do a demo with a different scope. Right. So here we have an application. It was created quite a few months ago, but then this is a new version, like V2, of My Conferences. It's an application for where you can manage conferences. You can create a conference, an event, and anyone can create their own conferences, and then any attendee or any person can register and go to that conference. That is kind of the domain or the business domain of this application. We even have several clients. There's a web client, Windows Store client. I'm going to zoom a little bit. A desktop application. I'm going to use this one on Thursday, which is a WPF application. Then those two are a Windows Store application for Windows 8. One is in HTML5 and the other is .NET. And then we have a client library, reusing code, using portable libraries. I will talk about that later on. And we have a web application, which is kind of the main application here. And something new in this version is that the web application is a SPA. It is a single-page application. It's not just MVC or web forms, but we are using a lot of JavaScript in the client side. So when you load the application, it's going to be in the browser, and then you will have just very few round trips, because most of the time the application is just using JavaScript, jQuery, and accessing services, but not reloading the whole application. So because it is a single-page application, we are using different frameworks, JavaScript frameworks. We are using Durandal, and then we're using also Knockout, so we can have view models and views. So the view models are implemented using JavaScript, and views is just HTML. And then if we go to main, we're also using require.js. So any JavaScript script or file that you need is going to be downloaded incrementally instead of downloading the whole thing at the beginning, which would be kind of slow. And also Durandal has something which is Durandal and Knockout. So, they have navigation. So with that router, you can load different view models and views, parcel views within your application without going to the server and reloading the whole page. You will see it later on when I'm going to run the application. What else? See, here you can see the views, which are just HTML. So for instance, the conference, in here we have just HTML, and then when I press the button save conference, I will call a method which is a view model in JavaScript, and it is here, the conference. Like you can search for it here. This is JavaScript, view models, and then the save conference is this method. And then in this case, we are grabbing that data and saving that data into the database through Web API services. So let's run the application, and you'll see how it works. Wait a minute. So you see that we just loaded the application. And if you take a look to the upper side, it's not going to be loading the whole page every time I'm navigating. So if I go to this session, for instance, in TechEd Madrid, you see we have transitions, and it's loading just a partial view. It didn't load the whole page from the server. So we are just calling services and using jQuery and grabbing that data, and that's it. Or if we go to view conference, so for instance, I can show you with F12, we can start the profiler. And then if I go to view conference schedule, in the network, start capturing, you see that, I'm going to go here. There are just 2 calls to web services, Web API services, you see, API conferences, get conference by ID. And if we go in here, you can see that what was traveling through the network is just data. It's JSON data. So if I go to, I even can check that out, copying this URL, and then I can paste that URL in another browser, and then I get just the data. I can open it, and this is what was traveling through the network. It's just data, JSON data, and that's it. Okay, so that is the application. But in this case, most of the application is just data-driven. We are saving conferences or reading conferences, updating conferences. It is data-driven. There's very little business logic in here. So that's why we have a subsystem or a bounding context, which is just data-driven. So if we go to that bounding context, which is called conference context, we have a model which is composed by entities, POCO entities, and then underneath we will use entity framework. But any entity here is just plain C# code, like a conference. We have the class here, conference, and just a bunch of properties, like conference ID, name, and that's it. And then that is what we need for this data-driven application. And what else do we need? We also need to have repositories. So we have that here. So those repositories is the class where we are using in order to save data in the database using link queue to entities. Like, for instance, conference repository. This is the class. And then we are just using, like in this method, get all with user info. We're using link queue to entities. So in this case, it's pretty simple. It's just, like I said, data-driven. But then we have another subsystem. I'm going to get into it, which is when we want to register to the conference. So if I want to register here, that second subsystem starts here. So the page could seem like the same application and could seem like data-driven, but it is not. So you could have many domain logic or business logic here, because when you are booking or you're creating you're buying a ticket, then you could have a lot of business logic in there, like a payment, or you get to check the number of available seats. There are different constraints that you're going to be aware of that. So that subsystem could have a different approach, could have a domain-driven design approach. And that's what we did here. In this case, the second subsystem is this one, the ordering context. So we also have a domain model, and we have entities. But in this case, the domain entities are not just data. We have like a rich model. If we go to the conference entity, you see in this case it is an aggregate root, which is another pattern, like a group of entities in your model. And then the entities are not just data. When a model is just data, it's what we call anemic domain model in domain-driven design. And this is not an anemic domain model because you also have logic within the entity itself. You see, we have all the properties, but then we have a method like change conference seats. So in this case, we gotta be aware if the conference is canceled, of how many number of seats are available. A different business logic we must to take into account when we are dealing with this data. Okay, so that's one of the differences when you are using domain-driven design approach. Then we also have the repositories in order to persist the data in the database, and we can have application layer where we can have services. In this case, a service is just a stateless class, like orchestrating the different domain logic. So if we go to the ordering service, here you can see that in the constructor, I have all the dependencies. I'm not just going ahead and creating an object using new, but I'm putting my dependencies in the constructor because I'm using dependency injection. So all the dependencies I've got in this service are in my constructor. In this case, for this service, I just need a repository and also the event bus because I want to integrate with this subsystem with another subsystem. So if you know something about dependency injection, all the types must be related to abstractions. Like in this case, I want to create a conference repository, and I say, okay, so it's going to be iConference repository. This is the interface I need. So when I'm registering or creating my IOC container, my inversion of control container, then in there, I'm registering all the types. Like when I need a conference repository, I need an interface, which is an iConference repository, then you would instantiate this class. Or if you need the ordering service, I need this interface, then it will instantiate this other class. But the beauty of this approach is that in the future, if you change the implementation, you would go and create a different class with a different implementation, and you would go here and just change. So when you ask for an object of that interface, the IOC container would instantiate a different object, different type, and so your code won't change. I mean, the code of the service, just the new classes is what you are extending, right? So I'm going to show you later on a good example, which is we are using an event bus. And right now, that event bus is using a in-memory bus. So it's just a place in memory where I'm putting data and reading data. But then just changing this registration here, we will be able to use a Windows Azure Service Bus without touching the code of my application, just adding another implementation class and registering that class here. So what else about, yeah, so I was talking about the event bus. So I'm going to show you the code. You can see here we've got a project called Event Bus. And my event bus is pretty simple. It's just what I need is an interface where I'm going to have two methods. One is publish. I want to publish an event that happened in one subsystem, and then I need to register event handlers. So the other subsystems must be aware of what happened in my subsystem. So it is following like a publish subscription approach or pattern. So if I want to subscribe my subsystem to the event bus, I just need to use the register event handler. Okay. But this is just the interface. So we can have different implementations. And the first implementation we had is, like I mentioned, an in-memory event bus. So in this case, this in-memory event bus is our own implementation. And we are using a hash shed, and then putting data and reading data from there. And everything is our code. But because it is in memory, it has a limitation. Everything has to be within the same process. So all the subsystems must be running within the same process. So if the application is web, all your subsystems should be running within the IIS process or the IIS application pool process in order to communicate through this event bus. So something happened here, I put that message or that class with data in this event bus, and then the other subsystem would grab that information, and then will act accordingly. But if you have different servers, then you would need a different implementation. So we have the same, we are following the same interface, but then we created a different implementation using the Windows Azure Event Bus API. So in this case, it's the same methods, publish and the message in order to register. But here you can see that when I'm creating a message and publish, we are using the Windows Azure Service Bus, creating a topic, and then sending that message to the Windows Azure Service Bus in the internet. So all the subsystems could be distributed in different processes or even different servers. So I'm going to run the application again. So you can see this code. I'm going to debug it, and you can see how it runs internally. So in this case, as I mentioned, we have the data-driven application or the data-driven subsystem where we are creating events or conferences. I go here and manage conferences. I create a new conference. And this is just plain data-driven. I just need a bunch of data here, like the name of the conference, a conference logo. Let's use TechEd Europe, demo, conf, TechEd Madrid. The date starts at 8. I think it's here. My description. City, Madrid. FEMA.net. TechEd. And then let's put like 200 people here for the available seats in this event. So when I press save in this subsystem, it's going to create a conference. It's just data-driven. But the other subsystem, the ordering subsystem, must be aware that we have a new conference. So that's why when I press save, a part of saving data, I need to create an event saying, OK, a new conference has been created here. I create that event. I put that event, that message into the event bus, and then the other subsystem, because it was registered to that event bus, is going to take it. Okay, so let's press save. So here are we in JavaScript. This is the view model in Knockout. So it is saving the conference. It is calling another JavaScript method, which is this one, where we are using jQuery, and from jQuery and JavaScript, we are calling the Web API service. So now when I go ahead, we're going to call that Web API service, and we have another breakpoint in the server, and that's going to be .NET in the server. So let's continue. And you see that now I'm now in the server. This is .NET. This is a Web API service called Conferences Controller, and it is Web API, AP Controller. And it is a REST Web API service, so using the HTTP verb post. And this web service, what it's doing is just calling a repository, which is taking that data and saving that data into the database using Entity Framework. So here I'm getting that data, saving changes in the Entity Framework DB context. And then once everything is in the database, this is the integration code. So what I'm doing here is I'm creating an event, which is conference created, because it just happened. So it is a past tense. And that event, like I said, is just a class with data. And the data I need, which is the number of seats and the ID, and that's the only data I need for the other subsystem. I don't really need all the name and address or whatever. I just need that data for the other subsystem. And then I publish that event into my bus. In this case, the bus is using the memory bus. It was everything my code. So everything's just within the same process. And when I publish it, I call that method. You see that the implementation of this event bus, it is the in-memory event bus. See here. And then we are just putting that data into the event bus, and then the other subsystems are grabbing that data. So if I go ahead, I'm putting the event into the event bus, and you see that now the event handler grabbed that message. So, and this is the other subsystem. You can see that here. You see that this is the ordering application and then the event handler. So this is the ordering subsystem. And here, I mean, we just grab the event, and we need to create that conference in the other database, the other schema, the other subsystem. So we just save it. So this is the way to communicate different subsystems asynchronously, right? Now, what happens if the other subsystem is not within the same process? Because everything in here was ASP.NET and MVC, so the same web. But what happens if the other subsystem is LightSwitch, the application I just showed you? So LightSwitch is also web, but it's going to be running in a different web application and a different website. So it's going to be a different process. So because of that, we won't be able to use the same event bus in memory. It has to be using a service bus, like the Windows Azure service bus. I have to send that message to the cloud or to my Windows Server service bus, and then use the distributed service bus. So I already showed you the implementation using the Windows Azure Service Bus. What I want to show you is this is the LightSwitch project. We have now quite a few tables, like the conferences, materials, and so on. And then what we want to do is, when I save a conference in LightSwitch, I want to propagate that using an event to the other subsystem. So in this case, we need just 2 lines of code in .NET about the conference entity in LightSwitch. So when the conference is being updated or created, what I'm doing here is I'm creating the event and then publishing that event into my event bus. So similar case, but now it's going to be distributed. If I run it now, it won't work because we were using the in-memory bus. But if we go to the Unity or your dependency injection container, and I just change this line, so when I need an event bus, it's not going to use the in-memory event bus. So I commented that. Let's stop it. But what we want to do is to, when I need an iEvent bus, we're going to instantiate the Windows Azure Event Bus, our implementation. And this is the only thing I need to change, like the dictionary or the registry within my IOC container. The rest of the application has not changed at all. So all the dependencies that I have, I didn't have to change it, just the registration. Okay? So if I run it, I'm going to run the application and then the light switch subsystem. So this is the web application running, and then I run the light switch application here. So it is a different website, could be a different server. So we have the event we created a few minutes ago, the demo conf TechEd Madrid. We can edit this conference. We're going to change the number of seats from 200 to 333. We save it. And this is a breakpoint within the .NET code in LightSwitch. So it is just creating this event, which is the data I need. Number of seats now is 333, and then I just publish that event. Okay, it is using now a broker message and the Windows Azure Event Bus implementation, and just we're putting now that message in the cloud. So if the network is working okay, it's going to work. And it worked. So it went to the cloud, and then this handle has taken the message from the Windows Azure Service Bus. You see this is the other subsystem or the other bounding context, ordering application handlers. And we got that message, the conference seats, and we are just updating that change into the second subsystem. Okay, and publishing, and that's it. Right. And now, let's move on to the presentation. Okay. And now let's go to the third area, which is about modern applications. You might be hearing a lot of information about modern apps, application modernizations, and so on. So in this case, I'm talking about modern business applications, which is related to the business. It's not just a modern app. It could be a game, a modern app, isolated phone. I'm talking and I'm focusing on modern business applications. You will see information like this in build as well. So this is like a trouble. We are coming from established patterns where we had servers and clients and applications, desktop applications, and so on. And we are moving to emerging patterns where everything is about devices, mobile devices, and services. And I mean, it's like changing the trends, and everything is more distributed, and any kind of device, not just Microsoft devices, but any kind of device. And the Microsoft vision about a modern business application is this slide. Probably this is the other most important slide I want to show you today. So up until now in this talk, I've been talking about established applications or established patterns. So we had foundational applications for the business, web or desktop, or my core application, domain-driven design, whatever. But in any case, we had small, medium business applications, more about data-driven or mission-critical. And the Microsoft vision is to evolve those applications, those current established business applications, and use also the emerging application patterns, which is about devices, mobile devices, and also cloud. So on one hand, we will be extending our applications to new experiences, like a tablet or a phone, and for new scenarios and new users. But because of that, because we might be getting many more users in the internet, for instance, probably we will have like unexpected requirements regarding availability and scalability. So that's why we also need the cloud in most of those scenarios. Could be also on premises, but a modern business application should also use the cloud for those scenarios. So on one hand, we are extending the business applications with new devices, but also we are evolving our services from on-premises to the cloud. And that's kind of the summary of what is a modern business application. So a modern business application is not just the isolated app in the mobile or within the tablet, but the whole thing, like taking into account what you already have in your company, in your enterprise. So basically, we are going from regular web applications for the desktop to modern web applications. What is a modern web application? It's a web application, HTML, HTML5, that it is also taking into account new devices, new form factors. So it is a web application using a browser, but then maybe you're going to have users using different or smaller form factor. Then native applications, we are coming from just desktop to different devices, Windows Store, Windows Phone, or even non-Microsoft devices, iOS or Android. And regarding services, we are coming from on-premises, your own data center, to the cloud, or even a hybrid cloud, which is part of your systems are in the cloud, but then you have a link, secure link, like linking the cloud with your on-premise data center. So let's do a demo about modern web apps and also about Windows Store apps. What's going on? So on one hand, LightSwitch is also a modern application, modern web application, because if I run it, and I forgot to show you this, you can see that you can use it in a browser, large form factor. But if you resize that, like I'm simulating that it is a tablet, a smaller tablet, or even a mobile, you see that it's changing now the layout and the size, and this could be also a mobile application. Okay, so it is using mobile jQuery, and that's why it is capable of doing that. And another example is just using MVC. So in my other application, the regular .NET application, we are using here in MVC, in the views, we have, like in the layout, the template, we have a regular layout that is going to be used when the browser is a regular browser in a PC, a large browser, or this other template with the extension mobile, and that's going to be automatically used depending on the user agent of the browser without putting your own logic. So I'm just going to run the application again, and you'll see that it's going to be like automatic. So here's our application, web application. If I resize it, okay, it's working okay, it's getting smaller, but it has a limit, right? If we have like a mobile, then it doesn't work okay. We would have to do a lot of scrolling and so on. So what I'm going to do is I'm going to simulate that this browser is a mobile browser. So if I press F12, and then Tools, Change User Agent, I'm going to simulate that it is IE10 for Windows Phone. And I'm going to reference the application. And then you see that the rendering is different. This is more like a rendering for a mobile. And if I change it again, it will change. Okay, and then regarding native applications, we also have, like I mentioned at the beginning of the session, we have different clients, like the attendee and the organizer. Those are Windows Store applications. You can see them here. And so the idea is when you have a business application, maybe the core or the large application could be desktop or could be web, but maybe you need different scenarios for a tablet or for a phone, just for a concrete scenario. So if I run this, now this is touch. I'm just touching the screen. I need to log in. We are using Facebook authentication. So in this case, this application would be for the organizer. It's like now an application that he's running on a tablet on the run. So while having the conference, he can go and see his event. He can come here and see all the sessions in this event, and then he can see all the comments about the session or the attendees. And then you could have another scenario which is for the attendees. So in this case, I gotta log in again. And in this case would be for the attendee, so you can check within the conference. You can see where's the event, or I can go to this session. I can see what Facebook friends I have in that session, or I can see the comments, or I could see notes that I could integrate with another application, etc. So it's different scenarios for different end users. And regarding this, I just want to highlight, because we don't really have more time, that we are using a library which is sharing code for all the .NET applications. So it is a PCL, a portable class library. If I go to the properties, you see that a portable class library, you can target different frameworks. It's not just .NET, but you can target, I'm going to zoom. You can target .NET Framework 4.5, so it could be code in a WPF application, or WinForms, or a service, or Silverlight, or Windows Phone 7, or Windows Phone 8, or even .NET for Windows Store applications, or even Xbox. And the beauty of this is it's not just code. It's a DLL. So you have the binary DLL compiled and can be shared between all those different platforms. Okay. Right. So we're finishing. This is like a summary of the session, positioning the different technologies depending on what kind of application you want to build. If it is a small, medium-sized application, or mission critical, and the different approaches and technologies, or the emerging application patterns and Windows Store applications, phone, and etc. And takeaways, like I said quite a few times, select your technologies and approaches depending on what are your business requirements, what is the application about. Do not try to have your top-level architecture and apply that architecture and that approach everywhere, because that doesn't work. You got to use different components. Like if you're creating a car or a bicycle, it's different, right? Then also, it's important that if you are creating a large application, depending on what kind of subsystem, and isolated subsystems, autonomous subsystems, you could use different approaches and different technologies as well. Like I said, you could have a data-driven subsystem using light switch, and then the core subsystem using a domain-driven design approach. And finally, you can also modernize your application with new devices, new technologies, cloud, like putting another subsystem, like a front-end subsystem or similar approaches. And well, a few resources, slides, and that's it. So with that, we are done. Thanks a lot. If you have any question, for every good question that you have, I will give you a badge holder with Visual Studio. So, anyone? Yeah. Is there any mic we can?
Thank you. Hi. I just have a housekeeping questions. Are we able to get our slides online?
Yeah. So I already published this demo, but it's a little bit older version in my blog, which is in MSDN Cesar de la Torre. But I'm going to publish this exact version the end of this week or next week in my blog and also within the MSDN samples. So you will be able to download the demo, the code and everything, okay? So, and if you just run it, and it's going to create a database in the SQL Express, so the setup is pretty simple, okay? So there you go. Any other question? Yeah?
What is the strategic Microsoft story on Silverlight, and in reference to Light Switch and the comment or the concept of HTML5? What are we to read into that point?
Yeah. So that's a really good question. So I'm going to answer just a little bit because we are going to say more things about that this week in Build. But let me say it this way. We can talk more later on, but I get to wait until Thursday because we are going to publish guidance and more. This session is like a summary of what we're going to say and publish documentation on Thursday in Build. But let me answer that way. If you can find Silverlight there, or you can't. Yeah, and then Light Switch, the old version was based on Silverlight, right? But now the new version is based on HTML5. So that is the strategy for Light Switch and moving forward, okay? You can have two because the question was really good.
Thanks, buddy. Cheers.
I was expecting that question. Not from you, but any other question? Yeah. So the question was what container, IOC container, I was using for the dependency injection. I was using Unity from Microsoft Patterns and Practices. But usually when you are using an IOC container, you should be calling that IOC container once in your whole application, because then the rest is just putting dependencies in your constructor. So if you want to swap to a different IOC container, would be simple. It's just changing 2 lines. So you could use Ninjak or Castle Windsor or whatever. Okay. There you go. Okay. Any other question? So the question was, is it okay to use repositories?
In your domain layer. I noticed you're using...
In your domain layer, yeah. So your domain layer should have, so this is a question about domain-driven design, okay? So patterns in DDD and so on. And the question is it okay to use a repository within your domain layer? So usually your domain layer should have just code which is regarding your domain logic. So you could be using entities, calling methods with domain logic within those entities, or you could have services, but services in this case is just a plain class, a stateless class. And then for sure, you won't have any repository implementation class within the domain layer. You should have another infrastructure layer where you are using the link queue to entities or nhibernate or any other technology for the implementation of those repositories. But what you should have within your domain layer are the contracts. So if I need a iConference repository, the interface should be within my domain because it's like a contract. I need that repository to work in my system, so the contract, the interface, is going to be within the domain layer, but not the implementation, because the implementation is going to be related to infrastructure technology. So today you could be using link queue to SQL, but then in the future you might change to link queue to entities and entity framework, and if you put that within your domain, you're putting dirty your domain with infrastructure and technology. Okay. Any other question? There you are.
Hi, my question is going in the direction of CQRS. Isn't that too much effort to always save the work or the changes in a repository and then do the same work on the service bus? So you have always to do twice the work. Is there no implementation
so
of just one
let me rephrase your question if I understood well. So the question is regarding CQRS, which is
pointing in this direction. So your implementation had always one repository instance and then the service bus instance, and you have twice do the same work.
Yeah. So the question is, in CQRS you have like two sides, the read sides and the write side. And then it's like you are duplicating repositories because you have two databases. One database is for the transactions and the write side, and the other database is for the queries. So everything goes faster from the screen when you are reading the information. And the question is, you are like duplicating repositories, and it's kind of more work. So on one hand, it's more work regarding that duplication. On another hand, when you have the reads database, it's less work for the screens and the queries, and everything is going to be simpler because you're going to have like a DTO table per screen, and then it's going to be much simpler. So the read side is going to be simpler. The other side is going to be more complex because it's not just executing a transaction, but then you gotta generate an event and publish that event in the event bus and so on. So I agree on that, and that's why I said that you should apply CQRS just within a single subsystem or a single, or not a single, but a concrete subsystem or bounding context, not everywhere. So maybe for a ordering subsystem could be okay, CQRS, because there are many people competing for the same resources, which are the number of available seats. So in that case, if you have a lot of users competing for that, CQRS is okay, but probably not for the whole application. That's the, and that's why if you heard sessions from Greg Young or Yudi Dahan, they even have a single session about when not to use CQRS, because it's in many cases.
Thank you.
There you go. Any other question? Because we are almost out of time. Okay, so thanks a lot. If anyone wants another, I've got more.